Hello everyone, welcome to our final unit of information. Yes, this unit of information, lesson 4 on work and energy, you will see questions on this on your final exam, so please take these 4 short lessons seriously. We will be discussing these next week, or the week after the paper box, so the final week in between paper box project ending and the final exam period. So we will be discussing this in class, but not during the paper box challenge, which is when you will be going through these videos. So without further delay, let's get started. Now this lesson is on work and energy, just as an introduction, so it is not going to be a very long particular video. You do have a series of questions that goes along with this. That first series of questions do kind of review a little bit of, there's a couple of questions on there from Unit 3 still, again, to reinforce your skill set on force, both vertical and horizontal. So please be cognizant of that. All right, so work and energy. What is work? Work is just simply using a force to move an object over a distance, okay? So on the next slide, you'll see that the formula for work is work equals force in the moving direction times distance. Now, up until this point in time, we've always been trying, in most cases, to get F net, okay? That is not what we want when it comes to work. We don't want F net, we want just the motion or moving force, okay? It is only considered work when you have both force and motion in the same direction, okay? And that's really the key distinction here, is that force and motion must be in the same direction. So if I have a box, okay, and I have a force of 10N going this way, so to the right, but let's say the motion of this box is going up and up. Force, this is motion. Force is different than motion. It's not going in the same direction. So technically speaking, there is no work done. For work to be done, force, let's say again this is 10N, must be in the same direction as the movement. All right? So if movement and force are in the same direction, we get work. Otherwise, we don't. All right? And you'll see some examples coming up here. So for example, a man pushes up against a wall, exerts a great deal of force, but does no work. This happens because the wall, there's the guy. Again, stop making fun of my awesome drawings here. So here's the wall, here's the guy. He's pushing with 100N. The wall is not going anywhere. There is no movement. So because there is no movement, there is no work being done. Hopefully that makes sense. So which of these list of 5 situations would be considered work? A scientist delivers a speech to an audience of his peers. A bodybuilder lifts 350 pounds above his head. A mother carries her baby from room to room. A father pushes a lawnmower. A woman carries a 20-kilogram grocery bag to her car. Give a second. Which one of those 5s, or which ones of those 5 would be considered work? Let's see if you got them right. Okay, only those 2 are correct. Only a bodybuilder that lifts 350 pounds above his head. Now remember, the force that it takes to lift an object is an upwards force, and he's lifting it above his head. So again, the motion is upwards. So motion matches force, that is work. A scientist delivers a speech to an audience of peers. He is exerting some energy, but there is no movement of anything there, so that's not considered work. A mother carries her baby from room to room. Again, the baby goes up into mom's arms. Mom moves horizontally. So force does not match movement. No work. A father pushes a lawnmower. Again, horrible drawing skills, I know. Deal with it for 2 more weeks. There's a lawnmower. He's pushing in the same direction, okay, as he's walking. Therefore, there is work being done. A woman carries a 20-kilogram grocery bag. Again, 20-kilogram grocery bag goes up. Woman goes forward. Motion doesn't match force, okay? Now, again, here's the formula for work. Yes, this is one of the ones that you'll need to know. Work equals force of motion times distance. The unit of work is considered to be the Newton meters, otherwise referred to as joule. So here on henceforth, we will be doing work has a unit of joules. Okay? Now, here's a practice problem real quick. If a man pushes a concrete block 10 meters with a force of 20 N, how much work has he done? So here's work. He's covered a distance of 10 meters times force of motion, which is 20 N. Work is 200 N. Not super complicated, right? That's about it. Oh, sorry, that's not 200 N. That is 200 J, because work is got the units of joules. All right, so 10 meters times 20 newtons equals 200 Newton meters, otherwise known as joules. Okay, so when you answer work problems, W has joules for the unit. So very important concept. Energy spent equals work done, otherwise known as W equals E. Now, in the previous chapter when we talked about energy, that was the electricity unit, we said that energy equals kilowatt hours. Okay, and that holds true in the electricity unit. When we're talking about mechanical energy, which is what we're in now, energy is also measured in joules, because remember, joules is for work. Work equals energy, therefore energy equals joules as well. For the practice problems and your problems that you'll see on your final, these are going to be interchanged. We'll either say, what is the work of this? What is the energy spent on this? That means the same thing. Just like force of gravity means the same thing as weight, work equals energy. Now from unit 1, the electricity unit, we had this formula, energy equals power over T. You can convert this to say T over here and T over here. That gets us power equals energy over time. Energy can be swapped out with work. Okay, this energy is the same thing. Energy can be swapped out with work, and we'll talk more about that in a later lesson in this unit. It will become important. That's why I wanted to introduce it to you now. So for this lesson, just make sure you realize and memorize that work is the same thing as energy. Both are measured in joules when we're talking about mechanical energy. And when we're in electricity, energy is measured in kilowatt hours. Okay? And that is the end of our slideshow. And I will see you in class, and we'll talk about this in a few days. Thanks, guys. Bye.